Lesson 3 here in Algebra 1. We're talking today about simplifying expressions using the product property of exponents. So let's kind of break down just that title here for a second. What does product mean? Multiplication. All right. An exponent is what? Exponent, as we see here, an exponent can be repeated multiplication in much the same way that multiplication shows repeated addition. Okay? So it's just expanding. It's expanded, or really even a condensed way of looking at multiplication. So if I have my base is the number 5 and my exponent is 3 or 5 cubed, then what we're actually saying is 5 times 5 times 5, or 5 times itself 3 times. Do we follow that? So if it was 5 to the 4th, it would be 5 times 5 times 5 times 5. Okay? So we've got our base number down here, which is being multiplied by itself the number of times with our number shown above. For how many of you is this review? Okay? Should be just about everybody in here. Okay? So the base of a power is the number used as a factor, the thing that's being multiplied. If the exponent is a natural number, okay, meaning that it is an integer that's positive, it indicates how many times the base is used as a factor. And I'm going to ask a little bit of a different question here. What if I take a number, any number, no matter how big or how small, or even a variable for that matter, and raise it to the 0 power? Does anybody know what happens? What is it? It's always 1. It doesn't matter if it's, if I take, my pen just quit writing there for a second. There we go. To the 0 power. The answer here becomes 1. Okay? So it's just kind of a side thing. It's not necessarily in your book in this lesson, but it's kind of interesting to know how many people actually know that and see that. I'd put it in my notes, that way I understand that nothing, even if it's a variable, if it was, 1,200,000, to the 0 power equals 1. If it was negative 37 to the 0 power, it would equal 1. Okay, just as a side note. All right. We move over here. Hopefully we'll get to see some things. And you'll see this chart in your book. You'll see things like if we use this phrase, 5 to the 1st power. Anytime I take something to the 1st power, what am I going to get from it? I'm going to get that same number back. So 5 to the 1st, that's just 5. I'm not multiplying it by anything. All right, and so my value is 5. 5 to the 2nd power means 5 times 5, I'm going to get 25. 5 to the 3rd, 5 times 5 times 5 is 125. 5 to the 4th, 5 times itself 4 times is 625. Just showing how it works. Obviously, we're not always working with the number 5. Am I moving too fast, or is this all, we can keep moving forward, we all get this, we all understand this? Do I need to slow down for anybody? Okay, no questions? We will move on ahead. All right, so the product of powers, meaning the multiplication of powers whose bases are the same, can be found by writing each power as repeated multiplication. Meaning I understand that 5 to the 4th is 5 times 5 times 5 times 5, but if I'm taking 5 to the 4th and I'm multiplying it by 5 to the 5th, I'm saying 5 times 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 5. So I end up taking these numbers 4 and 5 and doing what with them? Adding them. I've got I've got Algebra 2 and Algebra 3 and geometry kids that still struggle with the product power of exponents, because our natural tendency is, because all this is multiplication, what do you think people like to do with 4 and 5? They like to multiply them and write it off as 5 to the 20th. Okay? We are just adding them. Now, there is a property, if I end up taking an exponent to an exponent, then I multiply those exponents, but we're not doing that today. Okay? So in an algebraic sense, so long as that x isn't 0 for some reason, then x to the m times x to the n is m plus n. So we can even do it algebraically where I'm adding variables to each other. Okay? So we'll make it more complicated. We all feel pretty good so far? Okay. Order of magnitude, as defined as the nearest power of 10 to a given quantity. The order of magnitude can be used to estimate when performing calculations mentally. Hopefully this will make more sense as we get into our book. Let us, at this point, let's come over here. Hopefully, let's see, do I have, here it is. I can pull this up here. All right, so let's work out a few questions here. 2 to the 5th. What am I actually doing? Right, 2 times itself 5 times. Can anybody tell me what 2 to the 5th is? All right, let's do this. Let's do this mentally. What's that? Should be 32. All right, 2 times 2. That's 2 2's, right? What do I get? 4. So what am I going to do with that 4? Multiply by 2, right? 4 times 2. 8. What am I going to do with that 8? Multiply it by 2. What's 2 times 8? 16. I need one more. I need to multiply it by 2 one more time. What's 16 times 2? 32. All right, we got that. So we can do that. When we get into a question like number 2, where we have 2/7 to the 3rd. Okay, let's see how much of this we understand. What am I doing with the 2 and the 7? Multiplying them by themselves 3 times. So with 2/7 to the 3rd, can anybody tell me what 2 to the 3rd is? What's 2 times 2? 4 times 2, 8. So that's going to put an 8 there. But I'm going to do the same thing with 7 on the bottom. What's 7 times 7? 49. What's 49 times 7? Probably not one you're going to do in your head, right? Anybody tell me? What's that? What is it? 343. All right, so we've got 8 over 343. Can I do this in my calculator? Can I do the whole thing in my calculator? Yes, but what do I have to do with that 2/7? Put it in parentheses. Does anybody know why it has to be in parentheses if I'm going to plug it in a calculator? Order of operations. Basically, if I don't put this in parentheses, what my calculator sees is 2 divided by 7 cubed. All right, so what they're going to see is 2 divided by 343. Is that the same as what our answer was? No. So it has to be in parentheses so it knows that I'm taking 2 over 7 to the 3rd, not just 2 divided by 7 to the 3rd, right? Because I would have to, order of operations, do the exponents first, right? So just because your calculator will solve the question for you doesn't mean it'll give you the right answer. You have to know how to tell your calculator what you want it to do, okay? All right, let's see. Let's look at something a little bit more abstract. We've got y to the 8th times y to the 7th. I'm going to see if there's not more to that. Nope, that's just where it stops. Are there any exponents to add there? Can I do anything with the 8 and the 4? Why not? You're right, I can't, but why not? Why is this not like yz to the 12th? Okay, instead of using the word things, though, we're going to use the word bases. They're not the same base. Now, if this had been y to the 8th times y to the 4th, it would be y to the 12th, right? Okay, but because they're two different bases, I can't combine them, right? I can't do anything with the exponents. Now, I could call that y to the 8th z to the 4th, but that's as much as I can do with it. So my answer here is I actually can't simplify this any further. Okay, they have to be the same base. All right, let's come down here to number 4. All right, do I have any same bases in number 4? What's my common base, Blayton? Number 4. 9 in, no. What's my common base? Okay, so this is what I want you, okay. So base, exponent. All right, what are the bases here? N and M are my bases. What are my common bases? No, no, 9 is not a base. It's an n. N is my common base, right? Okay, so I have two n, so I have common bases. What can I do with their exponents? Add them. So I've got 9 and 5. So I have what? Add them. N to the 14th times m to the what? Third. Can I combine these? No, because they're not common bases. So my final answer is n to the 14th, m to the third. Okay? Does that help you out there a little bit? Okay? All right, same type of question with number 5. All right, number 5. Anthony, do I have any common bases? Okay, what are my common bases? X, well, not X with, but X and X, Y and Y, right? All right, so tell me how that works out. I'm going to get X to the what? Huh? Which is what? Okay. I subtract them, so I get X squared. Why would I subtract them? Product power of exponents tell me I'm going to do what whenever I'm multiplying bases with exponents. What do I do with their exponents? So you're going to say that that's X to the 8th? Add them, okay? Add them. So what should X be to the power of? 6. All right, go ahead and help me out with Y. What do I do there? Same thing? Okay, so I get Y to the what? 11th. Okay, 6, 11. How do we feel about this? Are we still struggling? Okay, let's see. We're gonna continue to do this until 9:38. So about 3 more minutes. That way you guys have about 10 minutes to work. Okay, but here this changes things a little bit. Notice that this is not it's not a fraction, right? Can I change it to a fraction? What is 0.6 as a fraction? 6/10 or what? 3/5. So that would be the same as 3/5 to the third, right? What's 3 to the third? It's not 3 times 3, right? Big common mistake that people make with this is they try to take 3 times 3. It's 27, right? 3 times 3 is 9. That's 2 of them. Times 3 is 27. Okay, what about 5? 125. 5 times 5 is 25. 25 times 5 is 125. Okay, so you could look at that. I could plug that in my calculator and get a decimal. We should get something like 0.216. Something like that. Go ahead and check it. Do I get 0.216? Okay. All right, go ahead and you just use your calculator. Tell me what you get with 0.6 to the 5th. And take it to 5 decimal places. Anybody? 0.07776. That is correct. All right. Got a couple more questions in us to do. Let's see if we can't do some word problems. All right. After planting a seed, you notice that it produces 2 leaves in 10 days. If it doubles the number of leaves it has every 10 days, how many leaves will it have in 60 days? Remember, we're going in 10-day segments. So whenever I solve this question, I try to just solve it common sense, right? How many leaves does it have in 10 days? It's got 2 leaves. So how many leaves would it have in 20 days? 4. In 30 days? I'm doubling. 8. Okay, we're not going by evens, so if you get stuck in a 2, 4, 6, 8, you're going to get the wrong answer. 40, 16, 50, 32, 60, 64, and you'd get the right answer. Now, there is a mathematically quicker way to solve this if we understand that basically what we're saying is that there are 1, 2, 3, 4, 5, 6. 6 sets, right? And we're starting with 2, so we're going to go 2 to the 6th. What is 2 to the 6th? 64. Okay? All right. All right, let's look at number 9. Anybody here feel lost so far? We're doing okay? Leighton, you kind of giving me like this squint. Can you see from back there?
Not really.
Why don't you sit up here? Okay? I can make it bigger, but you do know that you have this sent to you on your computer, right? Okay, so if you can't see it from all the way back there, you can pull it up back there for yourself. Okay, but if you're having struggle just seeing things in general, go ahead and move on up. All right, a burst of electromagnetic radiation, frequency of 1.6 times 10 to the 5th exahertz. 1 exahertz is 10 to the 12th megahertz. Each megahertz is 10 to the 6th hertz. What is the frequency of the burst of radiation in hertz? So this is how we would write this, 1.6 times 10 to the 5th. But then we're going to take that, if each exahertz is 10 to the 12th megahertz, okay, it would look like that. Do we understand? Okay, but after I've done that, we want just hertz, which is each one of those goes like this. So what are my common bases? 10, right? Now 1.6 isn't, but I've got 10, 10, 10, 10. So what am I going to do with the exponents on those 10s? Add them, right? So what's 5 plus 12 plus 6? 23. Okay? So there are this many hertz in 1.6 exahertz. And that's all. It's just once it left as scientific notation. Okay? I'm going to go ahead and stop there. I think that you guys pretty well understand, the stuff that's in 10 through 12. So I'm not too worried about that. I want you guys to be able to get started on your homework, and that way I can answer questions if you have them.